this one here, how would I solve that? Well, for now, you can do it the easy way, which is to use that graphing feature on your calculator. Y equals sine x. We already had that on the first one. And if you're using TI, you write y equals 0.8 and you find the intersection. If using TI 84 or whatever you're using. So this part is completely optional. It's necessary for TI-84s, not necessary for Casio. For Casio, you use, what is it, ysolve? We've used it before. It's one of these commands. Let's see if I can see it. Max, min, y-intercept. I think you went on to this one. That little side arrow, and it shows it to you there. I'm just gonna, no, I'm not gonna check. I'm pretty confident because we've done it before. Now, how many answers should you get for that? Pause. You're correct, 2 of them. Because if you remember what it looks like, from 0 to 360, it looks like this. This is 1, this is -1, so 0.8 would have 2 solutions. One there and one there. Okay? So you can do it graphically like this. I know some of you know other ways of doing it. Okay? I'm going to do that on another lesson with the little triangles and cast. If you never heard of cast, you're okay. I'll show you another way. Okay? And by the way, this part B of this question is the stupidest thing I've ever seen. So ignore that. Is there more? Oh yeah, here. I'm backing up. I'm doing the first question from exercise 11A. This one's kind of something a little more visual. There's a Ferris wheel planned for Alpha Park that is 70 meters, and theta represents the angle measured anti-clockwise from the y-axis. Okay. Why they do this to me is, I don't know, because this is the y-axis. As we know, this is the x-axis, and it's really irritating. There's your Ferris wheel, nice and round, and the radius of this thing is 70. Okay, and they want to find the angle for which the distance is 30 meters from the x-axis. So from here to here is 30 meters they want, and this is a radius of 70 meters, and they want this angle here. Okay, well that's not so hard because I don't even need any calculator or anything like that. I can just say, well, I know that this is the opposite side in the hypotenuse. That to me is sine, so sine theta is equal to 30 over 70. So sine, if I want to clean that up, is 3 over 7. Now, you do this on your calculator, and you'll get yourself one answer. And what is it anyway? Exit, menu. They say arc sine or inverse of sine. That's that symbol. 3 divided by 7, close the brackets. As you can hear, I'm making a mistake in my typing, and I got an error. Why is that? Because Casios don't automatically put brackets in. And now I'm getting really irritated, so I'm going to do it all over again. Arc sine, bracket, 3 divided by 7, close bracket. And it says it's approximately 25.4 degrees. Okay, but that's only one. There will be another answer where it is, again, 30 meters high here. Ooh, so the angle here, so remember, we're measuring, and I have to be careful here. They say measure the angle anti-clockwise from the y-axis. Okay, so it's not this they want. That's this angle, but they actually want, let's change color here. They want this angle. And they want this angle because there's 2 possible solutions. So what would that be? Well, my angle would be 90 minus 25.4, I would guess. So that would be 64.6 degrees. So that would be one answer here. And then the other one, I guess, would be negative 64. Because it's going either way. So I'm turning this way, and I'm turning this way. So I get two answers there. So why is it measured from there? I don't know. They just told me to. Anti-clockwise from the y-axis. So the calculator, remember, always measures from the positive x-axis. So that has to, you have to take that into consideration. And part B, change color here. So this one was A. B, a distance of 20 meters to the right of the y-axis. To the right. Okay, so they want something here that is 20 meters. So where would that happen on the Ferris wheel? Well, let's say here, and it could be here when you're at the Ferris wheel, right? So they want to know this angle, and it's measured, I don't know why. Anyway, this is 20, that's still 70. This is 20 is the adjacent side of this triangle. Sorry, it's getting messy. But adjacent side is cosine. Notice I use theta, the Greek letter theta, for angles instead of x's and y's. They tend to do that in math for trigonometry. So this is the adjacent side over the hypotenuse. So cosine theta is equal to 2/7. So theta will be equal to the arc cosine of 2/7, which will be equal to, back to the calculator, 2/7. It'll be 73.4. Okay? If you get weird answers like that, you may not be in degrees. So if you get answers other than that. So double check that again. Now that's this angle here. Now they want it from the positive y-axis, clockwise. Okay, so they want it from the positive x-axis, y-axis. Let's make that purple. And they want this angle here. So again, same deal. My angle will be instead 90 minus 73.4. So that will be 16.6. That'll be like that. What's the other one going to be? Well, I've got another one here. So this angle here. So what would I have to do to get that angle? Well, we're going to get too many colors. But I'm looking for this angle, finally. So what's that going to be? 90 degrees plus an extra, whatever I measured, 73.4. So that'll be 163.4 degrees. Those are my two answers for that one. So that was for B. And this was A. Wow, a bit of a mess there that I did, but I really hate this question. Maybe this one's more normal. Okay, last one. Jacob models an average monthly temperature in Warsaw. There's the equation. Nice. On this domain, fine. T is time measured in months. T0 representing the average temperature in January. Fine. Predict the average temperature in May. Okay. Feeling good about this. So, T0 is January. So February would be 1. March, April, May. If my numbers are correct and my fingers are correct, that means in this case t equals 4. Is that right? Yes. I feel good about that. That is May. Yay! So what's the average temperature? Well, T will be equal to negative 11 cosine 30 times 4 plus 7.5. Just stick that in the calculator, my friends. You'll get the answer. What's that? You want me to do it? Oh, fine. Negative 11 times cosine of 30 times 4. I forgot the brackets again. Plus 7.5. So according to me, it's 13 degrees Celsius. Okay. B, predict when the average temperature would be 0. Okay, so that will be 0 equals negative 11 cosine 30t plus 7.5. Now here you got a couple of choices. If you just do this, now this is interesting. If you rearrange the equation and try to solve for it, the problem will be that you'll only get one answer. And then you have to figure out how you get the second answer, because if you just chuck it into your calculator, it will only generate one answer. So here's the rule. If you're looking for the angle, or the thing inside of sine or cosine, that's the angle, this bit, you will generally get more. You can get more than one answer. It depends on what your domain is. Now this is going for a full year, which is a full cycle. So I'm guessing there's going to be two answers here. Okay? So you got to be careful. So this is the dangerous way of doing it, but it's more what, let's say, HL people tend to do. You isolate your unknown like this, and then you would finish off with negatives cancel out of this equals 30t, and then you would then divide by 30. And you would put that in your calculator, but you only get one answer. And then you have to figure out, how do I get the second answer? So it's a pain. So generally, I would even recommend to not do this. What you should do is simply graph this in your calculator. So you should use y1 to be equal to negative 11 cosine 30t plus 7.5. And if you're using a TI-84, actually you won't need to, because this is 0 and you can find your zeros. That's fine. But you can do this and then do an intersection. You don't really need that though, because these are zeros. Okay? So if you just graph this and find the zeros, you'll get your answers. Now, remember, if I go all the way back, what you're going to have to change the window, because here you've changed things. Your x minimum is going to remain 0, but your x max is no longer 360 degrees, because they've done a little transformation here. 30, that 30 in there. Now, what is my maximum? Well, they tell me in the question that x goes, which is t, from 0 to 11. So just put in 11. You can put a little more if you want, but your answer shouldn't go beyond that. So if you go negative 1 all the way to 12 or something like that, that's fine. The x scale, just make it 1, but it doesn't matter. Optional. Okay? Your y minimum, though, and your y maximum, you don't really know here what's going on, but I can figure it out with trig functions pretty quick, because if I look at this, the cosine ratio, the max of that will be equal to 1, and the minimum of that is negative 1. So the biggest value this thing can have possibly is negative 11 times 1 plus 7.5. Actually, it'll be the inverse. That'll be the minimum because of the negative in front of 11 inverts it. Anyway, so negative 11 times 1 plus 7.5, that gives me, I'm tired, what is that? Negative 3.5. So I'll make the minimum negative 5 or something like that. I can go a little beyond, it doesn't matter. It's probably good because you don't want to cut it too close. And then the minimum value of this cosine ratio is negative 1. That's always true. So negative 11 times negative 1 is 11 plus 7.5. So that's 18.5. So let's make it an even 20. So if you go like that and then graph it, it's going to look good. So this is very important that you can do this and do it fast. Okay, speaking of fast, I better wrap this up. So I'm going to leave that to you to solve for this. You should get 2 answers, your 2 numbers, and then you should probably, to speak to normal people, tell me just what month so you can kind of figure that out. Yes, that's it. I'm going to quit unless you really want me to continue, but I won't. Ciao.